Right, we're going to move on now to look at the different starting points that we need to be able to recognise and set up when working with partial fractions. So if we come across denominators where any of the factors are not linear or can't be broken down into linear factors by further factorisation, then the previous starting point won't work. So the first next step to look at then would be one like this, where the denominator, one of the factors, contains a quadratic where you can't break it down any further. You can't factorise that further. If that was -4, then you could, because you'd have a difference of 2 squares, and you could write it in a way that you could use the previous method. But when it's in a setup like this, there's a different starting point. So we'll now work through that example. Once we've recognized the starting point, from there the method is the same as previously. So we have 5x squared plus 4x plus 4 over x squared plus 4x plus 2. It's not top heavy, even though we've got an x squared term there and an x squared term there. If we were to expand that out, we'd have an x cubed term. So the numerator is of order 2, denominator order 3, so that's fine. Once we've spotted that we have that arrangement of factors in the denominator, the equivalence for this, over the quadratic part of it, we have to have an x term constant and a number term constant. So that would be x squared plus 4, and then this one is linear, so that would be the same as previously. So ax plus b over the quadratic plus just a constant over the linear part. If they were written the other way around, it would be a over x plus 2 plus bx plus c over x squared plus 4. Now what we're doing is to combine the fraction to work out what equivalence the numerator must have. So on this side we have that, and on this side, when we divide that in, it leaves us x plus 2. So we'll have ax plus b, lots of x plus 2. And then when we divide this in, it leaves us x squared plus 4. And you can see there that it's a bit complicated now if we wanted to start doing this by inspection. So I'll set out the method for comparing coefficients. Expanding this bracket, ax squared plus 2ax plus bx plus 2b, and expanding this one, cx squared plus 4c. So now to compare the coefficients, we got x squared terms. So we have an a plus c, and those values have to equal 5. X terms, I have 2a plus b, and they have to equal 4. And then number only terms, I have x 2b plus 4c, and they have to equal 4 as well. So I am going to rearrange into the bottom one. So I have an A plus C is 5, so from 1 I'm going to get A in terms of C. So A is 5 minus C. From 3 I'm going to get B in terms of C, and then I can write A and B in terms of C in the middle. So from 3, well, I can divide throughout by 2 and get B plus 2C equals 2. So B is 2 minus 2C. That's equation 4. That's equation 5. So I've used 1 and 3, so I'm going to substitute into equation 2 because I haven't used it yet. So 2A, instead of writing A, I'm going to write 5 minus C plus B, and instead of writing B, I can write 2 minus 2C equals 4. So I've got one equation now, all in terms of C. 10 minus 2C plus 2 minus 2C equals 4. 12 minus 4C equals 4. 4C is 8, so C is 2. So in 4, A is 5 minus 2, which is 3. In 5, B is 2 minus 4, which is minus 2. So I know A, B and C, so I can now rewrite my expression. So therefore the equivalent, well, I'll have to write the whole thing again, is going to be AX plus B. It's just, so I got C is that, A is that, B is that. So AX plus B is going to be 3x minus 2 all over x squared plus 4 plus C over x plus 2. Job done. So the method is the same, it's just the starting point that changes, and you have to recognize I have that internal x squared in there. It's a quadratic factor, therefore I need to have the ax plus b over that quadratic part. So back to the notes. That's cleared that. Then the final setup that we need to recognize is where we have repeated factors. Now a repeated factor is where the quadratic part, the square, is actually part of the factor. So what this is doing is it's repeating x minus 1 again. So you get your x plus 1 and then x minus 1 times x minus 1, which can be written like that. So this again has a different starting point that you need to be aware of. So if we look at EG4, we have 2x squared minus 2x minus 1 over x plus 1 x minus 1 all squared. And this is perhaps the strangest one to set up. With this one, each factor is going to have a linear constant, so we're going to have a over x plus 1. But with a repeated factor, we write it first of all as itself, just the x minus 1 part, and then again as its repeat. So we've got that one separate, then x minus 1 in its own right, and then again as a square. And in setting it out in that way, it will give us the partial fractions in their lowest form. Once we've set that up, the method is the same. So we're going to combine it, compare left and right numerators, compare coefficients, set up our simultaneous equations, and solve for A, B, and C. So if I write this as 2x squared minus 4x minus 2, just multiplying in that 2, that has to be equivalent to 2. So when I divide x plus 1 into that, I get x minus 1 squared. So a x minus 1 squared. For the b constant, when I divide x minus 1 in, it cancels one of those, and I'm left with x plus 1, x minus 1. And for the c, when I divide the x minus 1 all squared in, it takes out both of them, the repeated part, leaving me x plus 1. Expand out and compare coefficients. So this one, a x squared minus 2x plus 1. This one, x squared plus x minus x is no x minus 1 plus c x plus 1. Now compare coefficients, which I hate writing. So x squared terms, I have an a plus b equals 2. X terms, minus 2a, no x term, plus c equals minus 4. And number terms, x to the power of 0, I have a minus b plus c equals minus 2. So from 1, a is 2 minus b. If I put that in there, I can then get c in terms of b. So in 2 minus 2, instead of writing a, 2 minus b, plus c equals negative 4, minus 4 plus 2b plus c equals minus 4. I want to get c equals, so those going over, minus 4 becomes plus 4, so that cancels, leaving me minus 2b. That's equation 4, that's equation 5. So if I put those now in 3, instead of writing a, I can write 2 minus b plus c, and instead of writing c, I can write minus 2b equals minus 2. So what have I got? 2 minus 4b equals minus 2. Take the 2 over, I get minus 4b equals minus 4, so b equals 1. Put that in 4, 2 minus 1, a equals 1, put it in 5, c equals minus 2 times 1, minus 2. Okay, so my equivalence to that fraction is a over x plus 1 plus b over x minus 1 plus c, my minus 2 over x minus 1 all squared. And those are the three forms that you need to be able to recognize. So the method, as I've said repeatedly, is that the method can be the same every time, although you can do this bit by inspection with the more straightforward linear versions. The important thing is you can remember which form, which starting point links to whatever your initial denominators are. As long as you get that right, then you're going to get the maths right from there.